Good day to all. I am Philip Emmanuel J. Emilio from grade 8 Livernook, and I'm going to discuss about sequencing, arithmetic sequence, and geometry sequence. And I am going to answer some of them. So let's dive in. An example of a arithmetic sequence, and we're going to try and solve it. So as you can see, we got negative 9, negative 13, negative 17, negative 21. So do you see a pattern? The pattern here is if we a common difference here is if we is minus 4. If we so to find the next term, we get the last term and just add it with the common difference. So in order to find the next three terms, you just need to continuously add negative 4. So get this as this is the last term. So negative 29. This is the first, second. So get this as is this the last term. So there. Here is the next three terms. In order to find the next three terms, you just need to continuously add negative 4. So get this as this is the last term. So negative 29. This is the first, second. So get this as is this the last term. So there. Here is the next three terms. The next three terms are negative 25, negative 29, and negative 33. And now we are going to find the nth term rule. So this sequence follows a formula. So I'm going to write the formula. A sub n equals a sub 1 plus open parenthesis number minus 1 close times the difference. So here is the formula. You might be wondering what is this and this. I'll explain. A sub 1 represents the first term, which is negative 9. So it's the A sub 1, negative 9, A sub 2, this, negative 13, A sub 3, negative 17. It's like the order of the sequence, the number of the term. This is the common difference. This represents the negative 4 or minus 4. Now we're going to substitute the formula. First, we're going to expand these two. So, to expand these two. So, okay. So now we're going to just distribute negative 4 to each of these. So it's going to turn into 4 times the number equals negative 4 times negative 1 equals positive 4. Combine. After that, we substitute. So here, the final one. Now we're going to simplify further. So we're going to simplify the numbers. So these two, we're going to simplify these two. So, negative 9 plus 4 is 5. Negative 5. So, if we put it on a final product, so here is it. After all that, we got the nth term rule, which is negative 4n minus 5. If we try that with a number, we're going to check this out. So, times 1 minus 5. Negative 4 times 1 is negative 4. Plus negative 5 since they're negative, so 9, which is correct because it's the first term. Let's try the second term. Times 2 minus 5. So let's check if it's really negative 13. So negative 4 times 2 is 8 minus is 8. So plus 5 since they're negatives is negative 13. So we're correct on the second term. Let's check if the third term is, which is negative 17, is correct. Oh, 4 times 3 minus 5. Let's check. Negative 4 times 3 is 12. Plus 5 is 17. So the third term, the first, second, and third term are correct. So this n term rule is correct.
2,000 years later.
Here we have an example of a geometric sequence. But first, how do I know that this is a geometric sequence? This geometric sequence because the consecutive quotient is the number. So which means the common ratio. So four. Negative 1/4. So this is the ratio. And then so now that we have identified the ratio. Now, so from what I have observed from the sequence is that the sign alternates. So here one is positive. Here negative 1/4, which is obviously negative. Here positive 1/16. Here negative 1/64. So the sign alternates. Positive, negative, and so on. And also the one pattern also is that we also the denominators are multiplied by 4. Here 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. That's one pattern. The next term, we just multiply the current term, which is this, by the ratio, which is negative 1/4, to get the next term. And now we're going to find the n term rule. So this sequence follows a specific formula, which is I'm going to write down. Equals a sub 1 times that ratio, or this one. Now we're going to substitute. So here is the substitute version of the rule. Right now we're going to simplify this. 1 times negative 1/4 is obviously negative 1/4. So
핸드폰 속에 너와 나눴던 얘기들은 아직 남아. 꿈만 속에
So, this is now the end term rule. As you can see, we cannot furthermore simplify it. So, this is it. The end term rule. Now that we got the end term rule, we can now find the next three terms. Base of 5, base of 5, base of 6, base of 7. So, let's go. First, we're going to start with ace of 5, the first. So, we're going to follow that into rule. Active 1, 4, 5 because it's the number of the term. This one equals 4 from these. 5 plus minus 5 minus 1 is 4. So we're going to so here we're going to multiply with the exponent. So now it's positive. So 4 to the raised to the power 4. So it is 56. So now we got the fifth term. So we're going to write term. Next, we're going to find the sixth term. Now let's find the sixth term. So we're gonna follow the end term rule. The number of terms. This is the sixth term. Six minus 1 is obviously 5. You can use your calculator to line up. So 4 is the power 5. Is 1034. Now we have the sixth term. Now we're going to proceed to find the last term, which is the seventh term. Now we're going to find the seventh term. Follow the term rule. The number of the term is 7. So 7 is 1 equals 7 minus 1 is 6. Or is the power 6. So going to 4 raised to the power 6 is 4 4,096. So now we have the second term. So we have to write it down. So now we got last three terms. So yeah, we're done. Thank you guys for watching. Like and subscribe to my channel. Hope you learned something today. God bless. Have a blessed day.